All right, guys, happy Tuesday. We're going to go ahead today and go over fractions that have the same numerator. However, they have different denominators. So the pictures and the comparisons are going to change a little. We're going to go ahead and get right into the first example here. It says Eric and Natrel are making a poster for their science project. They buy the same size poster. Eric divides his poster into fourths. He covers 3/4 of his poster with pictures. Natrel divides his poster into 6. He covers 3/6 of his poster with pictures. Whose project has more space covered by pictures? How do we know? All right, so the key words in this word problem is they are the same size poster. They just decided to cut or divide the poster differently. So we have the they cover the same parts, where Eric covers 3 parts of his poster and Natrel covers also 3 parts. However, those parts are not the same size. So we have to look at it because now we have different denominators. Now for review, we know that the denominator tells us how many parts we're going to cut the whole. The numerator tells us how many parts we're shading. So in this example, Eric's poster has been cut into 4 equal parts. And of those 4 equal parts, 3 of those parts were shaded. And here is a picture of that example. Now Natrel has the same size poster, but he decided to cut it into 6 equal parts. And you can see his pieces here. Now he decided to also cover 3 parts, but these are 3 parts of his poster. So what I want you to notice is they're different sizes. That this piece in Eric's poster is much larger than one piece in Natrel's poster. Because Natrel cut his poster into more pieces, the more pieces or the larger the denominator, the smaller the piece gets. So if we were to compare this into pizza, one slice out of Eric's pie is much larger than eating one slice out of Natrel's pie. And that's what we need to focus on today. I still want you to just use visuals for support, but you will notice, and we've practiced this before, that the larger the denominator gets, the smaller the piece you're going to get out of whatever shape or topic we're discussing, whether it be pizza or cake. If you are getting a larger denominator, those don't mean that you're getting a larger piece. That means you're getting actually smaller pieces. So would you rather have 3 slices from this cake, or would you rather have 3 slices from this cake? So this number sentence says 3/4 is greater than 3/6. And do you guys agree? If you guys agree, then you are correct, because 3/4 is greater than 3/6. And if you were to rewrite the number sentence with 3/6 first, because remember we read from left to right, then we would say 3/6 is less than 3/4. So today we're going to focus on having a different denominator. Let's keep going. And here's examples without visuals. So when we practice this today during independent practice, you want to draw them out. And I went ahead and did that here for you. So that first one says 1/2 is greater than 1/4. Well, let's check our answers. Now some of you will already catch on and say, oh, I'll just look at the denominator, and whatever's the smaller one is going to be the greater fraction. Yes, for today, because we're keeping the numerator the same, you can easily determine that. But the moment we start changing the numerator, and it's going to be different numerators or denominators, then you would be more beneficial to draw it out. So I went ahead and drew out the first one right here. 1/2, they're saying, is greater than 1/4. Well, here are my visuals, and I make sure to draw the same size rectangle. Now each one has shaded 1. They both have 1 shaded. So I'm going to shade the one piece from the half and one piece from 1/4. And then you'll see my visual right here. And is 1/2 greater than 1/4? Did 1/2 cover more surface area than 1/4? And if you said yes, then you are correct. So that number sentence is correct. 1/2 is greater than 1/4. All right, let's look at the next one. 3/3 is greater than 3/4. So what they're saying is I cut one shape up into 3 parts and I shaded all 3 parts. The other rectangle I cut into 4 parts, but I only shaded 3. So is 3/3 greater than 3/4? And here's that visual. So looking at this, you can see that 3/3 or 1/2 is in fact greater than 3/4 because it covered the entire shape. So that whole pie or that whole shape is gone. So 3/3 is greater than 3/4. That number sentence is correct as well. And then the last one, we have 2/8 and 2/2. 2/2 is just another word for, what is it? 1/2. And here's that visual right there, where you can see 2/8 is a really small fraction compared to 2/2. 2/2 means I ate 2 slices of a pizza that was cut into 2 parts. That pizza is gone. But if I cut that same pizza into 8 parts and I said, oh, I ate 2 slices, there's quite a bit of pizza left. So that definitely is a smaller fraction. So 2/8 is less than 2/2 is also a correct number sentence. So do you guys notice any patterns here? Okay, if you said, well, the bigger the number is, or the bigger the denominator is, as long as the numerators are the same, the bigger the denominator is, the smaller the fraction. So this is the one time in math where the number, if it gets bigger in fractions and denominators, it actually means it's getting smaller. All right, let's keep going. All right, I want you to take a look here because this is where things can get a little tricky. They're asking each pair of models are the same size. Will this reasoning work every time? I want you to specifically look at the hexagon and see that one hexagon has been cut into 6, and I'm going to draw it bigger here on mine, and the other hexagon has been cut into halves. Are they the same? Well, the hexagons are both the same size, but does that mean that they will work for when you want to do models? Well, look at here. I'm going to draw this out here. I'm trying. There we go. Okay. So there's our 6. That's my best attempt at a hexagon. And there is my half. Now we can use these models to be equivalent or compare them. If I were to shade half of this, how would I be able to use that top model if I want to compare? Well, in order to be equal or compare it, then I would have to shade 3 of them. And then it would be a model that we could use to reason and compare fractions. However, when we are saying different denominators, that's the only way we could say that they're equal. Though that one representation, half and 3/6, are equal. But the moment we get tricky and say 1/2 and 1/6, you can still use it and say, okay, which one is the bigger fraction? So as long as that each individual shape is cut into equal parts, then you can use it for comparison. All right, so let's check for understanding today. Which comparison statement and reasoning is correct when referring to the same whole? So we want to look through each one and say, is this true? 2/3 is greater than 2/4? Is it 2/3 is equal to 2/4? 2/3 is greater than 2/4? and 2/3 is less than 2/4. So before we read the rest of the number sentences, I want to look at the first part. That's a testing strategy. We know B is not going to be correct from the get-go because they have different denominators. They are not going to be equal. So now we're deciding, is 2/3 greater than, is 2/3 less than, and then we can go on further. So first thing I'm going to do is draw this out. So I'm going to draw two rectangles of the same size, one in thirds and one in fourths, and both have 2 shaded. Now we know the rule that we said, well, the bigger the fraction, as long as it's the same numerator up top, the bigger the fraction, the smaller it is. But let's verify that with a visual, and here's your visual. Top one is 2/3, bottom is 2/4. We can obviously 2/3 is greater than 2/4. So we have 2 options left because only 2 choices say that. Choice A says 2/3 is greater than 2/4, and choice C says 2/3 is greater than 2/4. So now we have to read on the sentence to see which is our correct answer. So this is our reasoning, our why. A says 2/3 and 2 is greater than 2/4 because the size of the parts are smaller when there is a smaller denominator. So let's reread that again, listen in carefully. A is stating that the size of the parts are smaller when the denominator is smaller. Well, looking at our example, this top one here has a denominator of 3. This bottom one has a denominator of 4. So what that sentence is saying is the smaller the denominator, the smaller the piece. And do we know that to be true? No, we know that is false. That is not true. The smaller the denominator, the bigger the piece. So A is false, which leads us to believe that C is correct. C says because the size of the parts are larger when there is a smaller denominator, and we know that to be true. So C is the correct answer. All right, that's it for me today, guys. Go ahead and watch the Khan Academy video below me, and then work on your independent practice and exit slip. I will see you guys Wednesday. Bye.